The last video in this whole unit is about inverse graphs. And so we have looked at inverse functions, we've looked at inverse trig functions, and today my whole goal for you is that you might understand a very particular principle of graphs of inverses. And so hopefully at the end that's where you'll be. Let's first look at some of the inverse functions that we are aware of. Let's just start with a very basic. We understand we have y equals sine x here. So let's think about that. There's your sine curve, right? And if we were to look at the inverse sine graph, and for those of you that might remember, it looks like this. And I could keep going again, up and down, just very similar. But let's just start with those two. All right, now let's look at y equals x squared. Y equals x squared would look like this, right? It's a parabola, open U shape. Y equals the square root of x. Well, maybe we need to start with some numbers. 0 would be 0. 1, the square root of 1 would be 1, right? 2 we don't know because the square root of 2 we don't know. Let's start with 4. The square root of 4 would be 2, right? The square root, and may I remind you that it would be plus or minus. And so what we'd have here is we would actually have this parabola on its side. Interesting, huh? All right, let's try this one. 2 to the x. Maybe you don't know what that graph looks like, but I'll start you off. Let's try 2 to the 0. 2 to the 0, so at 0, it would hit at 1. 2 to the 1 would hit at, so at 1, we would hit at 2. 2 squared would be 4. 2 cubed would be 8. Let's try some negatives. 2 to the negative 1 would be 1/2. 2 to the negative 2 would be 1/4. 2 to the negative 3 would be 1/8. And so what this graph does is it looks just like this. All right, now how about log base 2? Now let's think of this. Log base 2 of 0. 2 to what power would give you 0? Never. Can't. 2 to, there's no power that would be. How about 2 to what power is going to give you 1? Okay, so that would be at 1. Log base 2, and again, I'm going to kind of manipulate this a little bit so we can see this a little bit easier. Oh, let's start with 2. 2 to what power would give me 2? 2 to what power would give you 2? Well, of course, that would be 1, right? And then what about if x was 4? Well, 2 to what power would give you 4? Well, that would be 2, right? 2 squared. And so we would keep moving in this way, all right? If we wanted negatives, right, or if we wanted fractions, rather, because we can't get at negatives, it would continue to look like this. Oops, I did that in the wrong color. So I'm going to just pen over that in the right color. I want my inverses in red. Now, do you see any similarities between these? Is there some way that if I give you a graph, and by the way, this is where we're headed, that if I give you some crazy little graph, how can I find the graph's inverse? How do I find the inverse graph? Can you see, and I want you to take a minute, and I actually want you to think through this. If you need to pause it, pause it. My hope is that you can actually look at this graph here, and you can almost see like a line that's splitting in between. A line that's splitting in between. A line that's splitting in between. And it seems, well, my graphs are a little weird, but obviously if I did this more accurately on a graph paper, you might get a better picture, that this is literally the same line, that this line and this line, isn't that crazy? And I know I kind of slanted this a little bit more than I should have. This line, they are all the same kind of line. Well, there's got to, I mean, these are vastly different graphs. How is this possible that the same line does this? Now, if you think back to what we did in the previous chapter or previous lessons on how to find an inverse function, what did we do? We set the equation equal to y, and then what did we do? We switched the x and the y. Now, if you could think back to Algebra 2 when you did reflections and rotations, one of the things, which one of the rules allowed us to switch just the coordinates around? All you did was switch it. See, all this stuff literally relates. It was a reflection in what we call the line y equals x. And that is the crux of it all. I told you at the beginning of this lesson that there was one thing I wanted you to learn, and that is this, that a graph of the inverse function is simply a reflection in the line y equals x. Let me say that again. The graph of the inverse function is simply a reflection of the line y equals x. So if I am given a function, here you're looking at a function, this lovely blue graph, and I want you to find its inverse graph, what I'm asking you to do is to take the line y equals x and reflect it. Now this will be easier for some of you than others, and so the best way I can describe of how to do this, how to break this down, because there's real no method. It's really for those of you especially who are spatially gifted, who can actually break things down and see this. You have this line here on the, if you can just see, I'm going to try, and it's hard to discuss without you being in front of me, without you seeing my hand. This section here that you see here is going up, right? So if I'm reflecting it, what's got to happen is it's got to move in the same way below. So what I basically want to do is take that section and I'm going to do the same thing below. See how it's, if we could draw perpendicular lines, we want these distances to be the same all the way through and just be able to draw a straight line. That's in essence what's happening. A perpendicular line coming straight through that, hitting this perpendicular. That's what you learn in geometry class. It swings through there and it actually hits in the same distance apart. Then in the same way, what we want is this little section here, this curved part, is going to do the same thing, same mannerism on the other side to look like that. And that would be the inverse function. That's how the graph would look. We can get as strange as we want. We could do some, I'll try to do the one that you had on the other side. And what I would do is I would take this line, y equals x, and I would draw it. And all I'm asking is that you just split those quadrants right in half, that's all. And so to graph this, we basically want to reflect it and I should have kind of come over here. Let's say I should have gotten closer. So it's kind of close, kind of come close. Oh, I need to come closer here. And that's what would happen, is we would basically want to reflect and do the opposite. So we kind of come out here, just like it came out on this side. We want to come in this section, come in on this section. We want to come back out because this came back out. And we want to kind of come into the axes like this is coming in. And then I'm going to cross over here. And I'm going to cross over here. And that's really what's going through my mind spatially as I do the inverse graph. I can make them as crazy as I want, but that's the idea as you're going through these. Let's look at one more, because those graphs are helpful as we're doing these. It actually helps us read information. And it may seem irrelevant at this point, but as we move forward in these packets, you're going to see the kind of questions that they will love to ask about inverse functions. This is a very big topic on the CLEP exam. So let's start with this. Given the graph of f of x, you got a graph, f of 3. What that basically is saying is when x equals 3, what is the answer? So I would come over here onto my graph, find 3. I'd look up. Okay, it looks like it's, 4 3/4 or something like that, right? And so, or, maybe it's supposed to, I guess I just didn't come all the way up. Let's just say, for all intents and purposes, that it's hitting there at 5. All right, let's try another one. F of 0, that means at 0, we're going to look up here. Okay, let's say that's 2. F of -3, okay, -3. Boom, there, it's -1. No problems, right? Just reading off the graph. When it gives us the inverse, so it's saying the inverse of 4, this is saying I'm telling you where the y is. I'm giving you the answer. So the alternative here is I'm saying when. Here's 4. When does it equal here? And then look. Oh, that looks like it's at 2. And this is saying, when does y equal 0? When does this thing actually cross at 0? Oh, there it is, -2. Do you see the difference in questioning? So when they give you the inverse, they're giving you the y. And you have to remember that they're giving you the answer. It's a good old Jeopardy game. So as inspiration, go watch your favorite Jeopardy episode. I'm sure you all have one, and sing that lovely 30-second theme song and enjoy.